Cool. So today I'm gonna be solving this problem. Read code 847. And I've actually done this problem yesterday, but I actually couldn't get this solution. But I asked ChatGPT what the solution was, and I'm going to attempt to explain it to see if I understand it. So there's a group of N members and a list of various crimes that they commit, and the ith crime generates profit I and requires group I members to participate in it. If a member participates in, let's call a, okay, so basically, um, th- this is dynamic programming. Well, this is part of like a dynamic programming like list of problems. So it's obviously dynamic programming. So I want to see what kind of repeated work um, we can um, reduce. So yeah. So how I'm gonna do it is, oh wait, it's not connected. Um, okay. Okay. So let's imagine. No, let's do black here. Okay. So, well, our DP array will be like something like the number of people that we've already like that are part of the crimes that we're committing, right? So number of just gonna write P, right? And then the second field would be like, well, how much money have we made, right? So like our profit, right? So given we've used this many people, how much profit um, have we made? And actually, and we want to return the number of schemes. So this is like this would represent like the number of ways we can get to this profit. So yeah, so given this amount of people and we can make at least this amount of profit, how many ways can we do that? And yeah, I mean, yeah, and you can break it down. Like if we were to do it from a top-down perspective, like top-down way, using like DFS or something, and memoization, um, you can look like, okay, we are at, so this is group, you're at, so it's 2 2, and we have profit 2 3. So let me just rub this out. Yeah, okay. So yeah, so for the first, for the start, we're at I equals 0, which is this first two. So we kind of have a choice of if we want to take it or if we don't take it. So our current, like the current amount of number of people is 0, and we've made 0 profit. And then at this point, we kind of want to like explore when we take it versus when we don't. So this is like don't take, and this one is take. So and then at this point, we would be at so we would take this 2, and our profit would be 2. And then for the third one, oh well, yeah, and then oops. Let's undo this. And this would stay at 0, 0 because we didn't take anything. And again, we have like another choice for the second I, right? So yeah, so we can either take or don't take. Oh, also in this problem, I didn't explain it, but this n, we have to have less than or equal amount of like people n. So we can't have that 6 people are involved in the crime. So that's like a case. So like a base case. So if our n is like this first bit, the amount of people who are participating in it are greater than our n, that means we return 0 because that's an invalid way, right? But yeah, coming back to that, we want to take we want to take the second, so this would become 4, and our profit is 3, so that's 5. And if we don't take, it would be 2, 2. This side, if we take it, it would be 2, 3. And if we don't take it, it would be 0, 0. Yeah, so now you can kind of see that there's 2 ways, these two, such that we have our min profit. Our profit is at least 3. Yeah, because 2 is less than 3, and 0 is less than 3 as well. So I'll write the code for that now. So that's kind of the idea of the problem. So I think the top-down method using memoization is a lot easier. But for the bottom-up solution, so it's a little bit harder to code up. So RDP will be, so yeah, it'll be 0. Yeah, the number of ways is 0. Yeah, so min profit for a range of n plus 1, because we want 0. And then min profit plus 1. Yes. Okay, yeah, and if we have 0 people and 0 profit, there's only one way to do that. So we'll just add that to that. So we'll just go through the groups. So for I in a range of length group, so we have like our group I equals group I profit. Okay, and then for the profits, actually for P in a range from min profit to minus 1 to 0. So we basically want to iterate through all of our profits and say, and we want to say, is it like, if we, wait, oh wait, no, that's not right. Okay, wait, so for, okay, yeah, so for the amount of men that we have in the crime, ranging from from n to group I minus 1. And you'll see why I do group I minus 1 later. For the amount of profit we can make in a range from our min profit to minus 1. Okay, the reason why we want to do this, it's because let's say the amount of men we're allowed is 5. So okay, yeah, so it's 5. We're allowed 5 men, and like the current crime that we're about to commit costs 2 men. So we want to see, like, to get the amount here, wait, so let's say our n is 5 and our min profit is, wait, what is it in this example? 3. Okay, we have a crime which takes 2 men and results in a profit of 2, right? We want to see from the, like, for each amount of men, so from 5, 4, 3, 2, 1, we want to see, like, if we have 5 men, how many ways can we get to our profit? Wait, that doesn't make sense. That doesn't make sense how I explain it. Yeah, so for each amount of men, we want to see, like, our profit. So from 3 to 1. We want to see, like, the amount of ways we can get that. So let's say we're at 5, 3, right? Well, to get to 5, 3, it's either that, well, we want to save the amount of ways we got to 5, 3. So dp 5, 3. Well, that's equal to the current amount that we have, right? We don't want to lose that. But we also want to plus, like, the dp of, if we commit this crime, right? If we take this, it means that we need to look at the amount of ways we can get to 5. Like, we basically have to take the difference of these two, right? So let's just do that and that. And what this is saying, it's like, if we want to get to 5, 3, it's the only way we can get that is if we took this crime 2, 2, from a point where we had only 3 men. We only had 3 men and 1 profit. Oh my god. And 1 profit. So the amount of ways we can get to this, we have to add it to 5, 3, because we can get to 5, 3 from 3, 1 by committing this crime. And we want to do group I minus 1 because we don't want this to be negative, because we can't have negative men. But we want it to be that, but we can't do but we can't do it to where profit is wait. Yeah, but we can't do it to, like, we can't do from min profit to profit I minus 1 because let's say our min profit is 3, but a crime costs 6. But by the code, it won't run once. But obviously you can see that if you add the profit, like if you add that crime, as long as the group I is like the amount of men is not negative, if you like no matter how you add it, your min profit will be greater than the min profit. So like as an example, let's say you have okay, let's say you have a crime that takes 1 person, but it results in 10 profit. So if that means that for any amount of men that is like such that we have at least 1 man, so like this RM has to be greater than 1, which is kind of what this line is saying, right? We want it so that like, well, we can't have negative men. Oh, this is such a bad explanation, but we can't have negative men. So our M, like for any value of like m minus 1, for all the values of m, such that m minus 1 is greater or equal than 0, if we commit this crime, it'll be like a way to commit the crime, right? Yeah, well, it's one valid way. So I'm just gonna do it, bro. Yeah. So like, if profit I is greater than min profit, for all of these m's, it would mean that like if we add it, that's an extra way. But also we have to note that if min profit, if our P minus profit I is negative, we have to use 0 as the default value, because like you can't have negative profit. So like is dp of mp plus the dp of, if we had m minus group I men and the max between 0 and P minus profit I. So yeah, the only way we can get to M and P is if we got there from M minus group I with this amount of profit. That makes sense. And then return P. So N winner up. So it'd be the sum of dpi min profit for I in a range of n plus 1. And then we have to mod this. And we can just add the mod here. Yeah, and that's a pretty good solution. But yeah, I think the tricky bit for me, it was initially when I read the solution was this bit. But if you think about it, it's like for all the possible profits that we could be at. To get to that profit, we need to be at P minus profit I. Like if we took that crime, it would be that we were at P minus profit I. But if that was negative, then the only possibility was that we took that profit. We took that crime when we had zero profit, because we can't have negative profits, right? So yeah, I guess that's how I think about it. But yeah, maybe that wasn't the best solution or explanation, but yeah. Okay, the second one. Okay, I also didn't get this one, but I do understand how it works. So if you think about it, you kind of just want to split this list in half, such that yeah, you kind of want to split it into as equal halves as you can, right? So if we go through this first case, we can see that they took 2 and 4 together. Wait. Oh yeah, okay, yeah. You basically want to have two halves to this list, right? So of this list, 2, 7, 4, 1, 8, 1. You kind of want to split this into 2 equal halves. Well, this isn't equal, but 2 equal halves, such that the sum of these minus the sum of this is as little as possible, right? So how like in the first example, yeah, for each number you want to take a number from like this list and this list, and you want to minus it. So it's basically like the sum of this minus the sum of this. So for the first example, they combine 2 and 4, which is the same as like adding 2 to this list and 4 to this list. And then they add 7 to this list, 8 to this list, and then the 2, am I missing a number? No. Yeah, and then the 2 1s go on this list. Right? So yeah, so this would equal 10. Wait, did I pick that correctly? Oh wait, no, they did it. Oh wait, sorry. They didn't have the 2 1s there. They had the 2 1s here. Yeah, so this would be 11, and this would be 12. So we kind of want to just split the list into 2, and a way we can do that using dynamic programming, it's so basically our new target is the sum of our nums, right? Nums divided by 2. And we want to find, so like a plus b, where a and b are the sums of these two lists, equals obviously the sum of the whole numbers. But we want to actually find the a such that a is less than or equal to b, because a, like, because b equals a plus like a little bit. I'm just gonna say that that's like some epsilon, some variable, right? Because like, yeah, so like let's say this was a, right? And this was b. Our b is essentially a plus a little bit. So we don't want to find this, because there's no guarantee that the remaining of the list, the remaining bit of the list is like, actually, I think it would work. I'm not too sure. I have to think about it, but yeah, that's why we did the integer division. It's just rounded down. So yeah, so we want to find like the a such that a is less than b, and a plus b equals the sum, because a plus b is essentially equal to a plus some little extra bit, which equals s. Okay, so yeah. So how I'm gonna write that is, so our total equals the sum of the stones, and our target equals the total divided by 2. Yeah, and how this relates back to dynamic programming, it's let's say, so we're gonna have our DP in a way such that DP, we're gonna have some max capacity, which is our target basically. And if we're at this max capacity, what is like our total sum? So what that's saying, it's like, if our max capacity of like our bag or our sack, what is the amount of like stones in terms of weight can we carry? And then that's basically our A. So yeah, so our DP equals 0. 0 times our target plus 1, where the DP is like max cap and then max sum, because we want to see that, okay, if like what we're trying to look for is half of this list, how close can we actually get to that target, right? So for stone and stones, for I'll just say target T. Yeah, but I don't think, yeah. So for every target in a range from our target to stone minus 1, I think, because you'll see, it's the symmetric. I mean, you don't have to do it. It's just like, it's for indexing. You don't want to have it. Wait. Yeah, it's just for indexing. It's like, it makes indexing so much easier. Okay. So our DP at the target will equal the max of DP of target. We're comparing the two. So to get to our target point, it would be that if we were at target minus stone, right? So let's say our target was 5 and our stone was 2. Equals 2. The only way we can get to this target is if we were at target 3. If we were at target 3 and we took in the stone, right? Yeah, and that will have like a max sum, and we have to add our stone to that max sum. And I think that's basically it. And then we can, okay, wait, well, our A equals our target, wait, our DP at our target, right? And okay, wait, I'll just rearrange. I'll do some algebra. So so A plus B equals our sum, right? And we kind of just want to find this little epsilon, this little bit. So we kind of want to do some rearranging. So we know B is A plus a little bit, which is our epsilon. So to find this epsilon, it's just the sum minus 2A. And we know our A is the max sum, like the max amount of stones we can carry if we had a capacity of target. So we just have to return the total minus 2 times dp of target. That should be right, if I'm not mistaken. Yep. Yeah, and I'm not sure if this matters, but I remember reading somewhere that this max function is actually it makes it slower. It's like a bit slow or something. So I wonder if we just do this. If we'll make it, if we can get a little bit faster. Well, a little bit. Let's submit it one more time. Okay, cool. It's just gonna stay there. Okay. Target sum. Okay. I think I did solve this one by myself. But I did it like top down using memoization because it's the logic is very clear. It's either it's just yeah, you just go through the whole list and you kind of just brute force it, and you like, oh, if we're at this index, what happens if we get what if we just minus our like current sum? Like we'll keep track of like the index that we're at and our current sum. Okay, what happens when we minus this, and we just keep going and we go here and then we go here. So yeah, I mean it's pretty simple. I can show you the code afterwards. But I was reading up the solution from ChatGPT, and basically we know that so for our positive, like a positive like n, so positive like the numbers that we, n represents the numbers that we pick that are positive, and then plus the number of negatives, the numbers that we pick. Well, I'll write this n2 and 1 equals our target. Our target. Oh wait, this is this should be minus. Minus, yeah, and then, but we know that the sum of these two. So n is not inherently negative. N just means that these numbers are the numbers we pick for them to be negative, and we just sum them up and like minus it from our positive ones. But we know that if we don't do that, if we don't make the sum of our n2 to be negative, this would just equal the total. So we So if we want to find the number of ways we can pick. Okay, wait, and then yeah, well, I mean, I guess it's kind of hard to get to this without knowing the problem, but if you combine these two, this would be 2p(n)(1) equals I'm just gonna write target like that plus to, and then p1 equals n1 yeah. So if we want to, we kind of just I guess it's like really hard, like I don't think I could have came up with this, but yeah, we kind of just want to like find the number of ways we can get to this this new target, right? And if we find the number of ways to do that, basically all the numbers that we didn't pick to be positive will be negatives, I think, right? So let's say in one of them, this wait, okay, wait, I'll just see. So 5 plus our target, which is 3 divided by 2, that equals 4. So we want to find the number of ways we can pick numbers, positive numbers, so that they sum up to 4. And if we do that, that just means that all the numbers, all like the numbers that we didn't pick will basically like be negatives, and by our equations over here, it'll equal the target. But yeah, it's a little bit abstract, I would say. Hard to see why that would be the case. But yeah. Well, okay, enough. Well, we'll just get to the code. Yeah, so the total is gonna be the sum of the nums, right? And yeah, and then if I know I'm missing something, I definitely know I'm missing something. So we'll just say new target equals target plus total divided by 2. Actually, wait. Yeah, you kind of want you have to check that it is divisible by 2, because if it's not, that means that there's no such ways to pick this Pn. So you just return -1. Well, you don't return -1. You return 0 because it's impossible. Yeah. So if our total plus target mod 2 equals 1, we just return 0. But I remember reading the code. I know there's something missing here, so well, I'll just leave it for now. New target equals yeah. And yeah, how do we transition between them? Because oh yeah, it's the number of ways. So dp is yeah, so if this is the target, this would equal the number of ways to get to target. So for Yeah. 0 times new target plus 1. And dp of 0, if our target's 0, there's only one way to get there, which is to do nothing. So for num and nums, it's the same formula for t in a range of target to num minus 1. dp of t equals dp of t plus dp of t minus num. Am I missing something? And then, yeah, so the amount of ways is for this target plus the number of ways for this target minus 1. And then we can just return dp of target. But this, I'm very not confident on this. Oh wait, maybe new target. Yeah, so on the second iteration, we're saying, oh, it's, yeah, because it's plus or minus, right? Oh, I think I know. Yeah, so basically what this is saying is on iteration 2, there's two ways to... Oh, wait, no. Wait, okay, wait, no, it's not this. It's not this, because if the target is 0, there are a lot of ways to get to 0. Because you can plus 1, minus 1, right? So, I think we need to make a new DP every time. Right, and our new DP of this T, of our target, will be the one from the last. Would it not just be... Yeah, we can't save the one from last time. We can't, because you have to take it. There's no not taking it, right? So would it not just be that, and then you change this DP to your new DP again? Oh, if t plus num is less than less than or equal? Yes. What? Oh. Would it be this? No. Oh, because everything stays at 0, right? So wouldn't it be 1 plus this thing? can we print dp? Whoa. Wait, what? How did that work? Yeah, I see that. Or maybe it's read that. Okay, so on section 1, there's only one way to get there. Oh wait, no, this is not. This is how I approached it at first, but you have to be able to go into the negatives. Maybe it's would it be similar to this one? Oh, I'm not too sure. I think this one is just a lot easier if you do top down. I don't know. I'm not too sure about the solution to this using like bottom up dynamic programming, but I did do this one, which is top down, and it's a lot easier in my opinion. What was this one? Oh, this is just yeah, this is basically the top down version, but like see this one. Oh yeah, see, this is what I did before, but I don't think this accepted. This one's pretty easy. Okay. I'm not too sure. I guess I can do this one tomorrow because I still don't fully understand. I understand these two. Well, at least in my mind. But yeah, okay. Thank you.